Hi, Math 30-2s. Carrying on with probability today, what we're going to discuss is what we call mutually exclusive events and what we call the events A, and the symbol that you see here, okay, this symbol here is or stands for or, okay? So when we see that, we're going to say or, so that's A or B, okay? So in the title here, it says the events A, this is or, B, and this is A and B. Okay, so there is going to be a difference between the word or and. So just below that, it does say in mathematics, the event A or B, okay, which again is written like this, is said to occur if the event A occurs or if the event B occurs or if both events occur. Okay, so or is what we call inclusive, one or the other or both. The event A and B, written like this, okay, occurs if both event and event B both occur simultaneously, okay, so at the same time. So what you're going to see today is that you're going to be starting to use your formula sheets, okay? So I'm just going to write these out here, but we will get them in our notes moving forward here, and I'll show you where they are in the notes. But we're going to have two kind of scenarios or situations today. Okay, we're going to talk about events when they are what we call mutually exclusive. Okay, so mutually exclusive events, we're going to have a formula for mutually exclusive events, and that's going to be the probability, okay, of A or B, which will equal the probability of A plus the probability of B. Okay, so a pretty straightforward formula. When I talk about events that are not mutually exclusive, okay, they are not mutually exclusive. Okay, I'm going to have to find that formula in my formula sheet, and we write that as the probability, again, of A or B. Okay, but this time the formula is the probability of A plus the probability of B. So the same start as the other equation, but now I subtract the probability of A and B. Okay, so that's the difference between the two equations. Those formulas are on your formula sheet. What I would do is I would go to that formula sheet right now, and beside this formula, write mutually exclusive, and beside this formula, I would write not mutually exclusive, because that's going to be a big decision we make going forward here. Are the events mutually exclusive or not? That'll determine which formula we use and how we calculate the probability. Okay, so investigating mutually exclusive events. So if you take a look at that title and the two circles they've drawn there in the Venn diagram, what do you notice? They're not overlapping at all. So mutually exclusive events will have no things in common. Okay, that's what we're going to focus on here. So consider the experiment of rolling a die and noting the result. Let A be an even number is thrown, and B is going to be an odd number is thrown. Mark the outcomes of the experiment in the Venn diagram, which represents the sample space. So in A, we're going to throw the even numbers. So the even numbers are going to be 2, 4, and 6. And remember, because I'm talking about the actual numbers themselves, I put dots after the numbers, okay? And then the odd numbers will be in B, so that's 1, 3, and 5. Okay, there are no numbers that don't fit into either circle, so nothing outside the circles, but still inside the box. Okay, that's all that we have to do there. So list the outcomes for A. Well, event A was the even number, so curly bracket, 2, 4, and 6. Those are the numbers. Okay, event B, okay, again, those were the odd numbers, so that's 1, 3, and 5. Now, the event A or B, okay, so remember A or B means one or the other or both. Well, there is no or both here, but one or the other, well, it's going to be all of those numbers combined, isn't it? 1, 2, 3, 4, 5, 6. Because if I pick any of those numbers, I could say they belong to circle A or they belong to circle B, don't they? And then lastly, the event A and B. Remember, this means and B. Well, there is no overlap. So this is what we call an empty set. Okay, there are no values to write there. They have nothing in common. Now, part C. It says, let n of A represent the number of outcomes in A. So remember, when we see that little n, that's the number of. So what are the number of events in A? Well, there are 3 numbers in circle A. The number of events in B, how many numbers in circle B? There are 3 in there. the number of events in A or B, well, that's all 6, 1, 2, 3, 4, 5, 6, and the number of elements or events in A and B, well, that was 0. There were none, okay? Now we're going to do probability. So what was the probability of event A happening? Well, the probability of event A was 3 results out of a total of 6, okay? So that results in 1/2, okay? The same thing is going to happen with B, isn't it? There were 3 results out of a total of 6, so that's 1/2. The probability of A or B, well, that was 6 out of 6, right? 6 results out of a total of 6, so that's 1. And the probability of A or B, well, that was 0 results out of 6, so the probability of that happening is 0. In this experiment, A and B have no common results, so therefore they are mutually exclusive. Notice that in the Venn diagram, the circle A and the circle B have no area of overlap. The sets are what we call disjoint, okay? So if they do not overlap, the sets are disjoint. So verify using the following. So this is just a formula they want me to fill out. So remember, N stands for the number of. So the number of events in A or B, okay? This here, the left side, was 6. Okay, that should equal the number of events in A. So the number of events in A was 3, plus the number of events in B, that was also 3. So 6 on the left side, 6 on the right side. Okay, the left side equaled the right side. We verified exactly what they wanted me to verify. Okay, then P stands for the probability. So remember, the probability of A or B, we take a look at that. That was 1. We calculated that. That should equal the probability of A. So what was the probability of A? 1/2. Plus the probability of B, that was also 1/2. Okay, so 1 is equal to, this will be 2 over 2, which is also 1. Okay, so that checks out. And again, the left side is equal to the right side. Okay, let's turn the page. So now we're going to investigate what we call non-mutually exclusive events. And what you notice right away here is that there is an area of overlap. So when they do overlap or they share some commonality, okay, they are what we call not mutually exclusive. So consider the experiment of rolling a die and noting the result. Let A again be an even number is thrown, and B is going to be the event. It's a multiple of 3. So mark the outcomes on the Venn diagram. So what we're going to do is this. In A, I know an even number is thrown. So an even number is thrown is going to be 2, 4, and 6. 6 goes in there, but because 6 should also be in circle B, it goes in the middle. 6 is an even number, but it's also multiples of 3. Remember, multiples of 3 will be 3 and 6. That's it on a die, okay? That means the numbers 1 and 5, which are part of the die, okay, do not fit into either of those categories in this case, so they are on the outside of the circles, but still inside what we'd say the universal set, or inside the rectangle, okay? So list the events, or the outcomes, pardon me, for event A. Well, for event A, that means what's in circle A? Well, that's the 2, the 4, and the 6. Okay, that's what's in circle A. What's in circle B? Well, that's just the 3 and the 6. Okay, what is in A or B? So that means you write down everything in those circles. So that's going to be 2, 3, 4, and 6. And then the event A and B, right? Remember, that stands for and. That's just the number 6. That is the only value that exists and is common between those two sets. Okay, we move on to N now, which is the number of. So the number of elements in A, that's 3. There are 3 numbers in circle A. In circle B, there are 2 numbers. A or B, there are 4. And A and B, there is just the 1. So again, then we talk about the probabilities. So what's the probability of A? Well, there are 3 numbers in circle A out of a total of 6. Again, that results in 1/2. The probability of B, well, this time it's 2 numbers in that circle out of 6, which reduces to 1/3. Okay, A or B, that was 4 numbers out of 6. That's 2/3. And then A and B, well, that's pretty straightforward. That's 1 value out of 6. Okay, so in this experiment, they have common outcomes. Therefore, we say they are not mutually exclusive. Notice that in the Venn diagram, the circle for A and the circle B have an area of overlap, okay, which is A and B. They are not disjointed sets. Okay, and again, verify the following formulas. Okay, just again, filling in values based on calculations we did up above. So the number in A or B, okay, we saw that was 4, should equal the number in A, that's 3, plus the number in B, that was 2, minus the number of elements that belong to both. So 4 on this side, 3 plus 2 is 5, minus 1, which is 4. Okay, and again, left side equaled the right side there. Okay, then we move on to the probability. So the probability, and we calculated these up above, the probability of A or B, that was 2 over 3. Okay, the probability of A was 1/2. The probability of B was 1 over 3, and minus the probability of A and B, that was 1 over 6. So 2/3 on this side, common denominator on the right-hand side, which would be 6, okay? You will get 4 over 6, which is 2 over 3, okay? And again, that works out as well. Left side is equal to the right side. Okay, so they are mutually exclusive if they have no common outcomes. Two events are mutually exclusive if, okay, the probability of A and B is 0. Okay, so that's mutually exclusive. Remember, things are mutually exclusive if they have no common outcomes. This was what we did on the first page, and this is important. The probability of A and B then is 0, okay, because they do not have anything in common, so the chance of that happening is 0. Okay, so here are the two formulas I actually gave you on the front page. So again, if you haven't done it at this point, go to your formula sheet and label them appropriately, okay? So this formula for mutually exclusive, this formula for not mutually exclusive, okay? So we're gonna use those moving forward here, okay, in the next two and a half pages with questions, okay? In each case, state whether the events A and B are mutually exclusive or not. So what are you asking yourself? You're asking yourself if the things can happen simultaneously or if they share any common outcomes. So in A, it says experiment, a die is rolled. Event A, an even number occurs, and event B, an odd number occurs. Well, those two things are mutually exclusive, right? They're mutually exclusive. They do not share anything. You can't roll a number and have it be an even number and an odd number. Okay, can't happen. In B, okay, a card is drawn from a deck, a standard deck. A face card is selected, and a club is selected. Well, those are not mutually exclusive, okay? You can have a card that is a face card and is still a club, right? So not mutually exclusive. And lastly, it says 2 dice are thrown. The dice both show the same value and the total is 11. Okay, well, those are mutually exclusive, right? You can have 2 die that are thrown that have the same number show up, but that'll never be 11. 5 and 5 is 10, 6 and 6 is 12. There's no way of having the same number and adding to 11. Notice that the mutually exclusive events in an even number occurs and an odd number occurs are complementary events. Okay, remember that's the opposite. Complementary events, okay, important point here, okay, will always be mutually exclusive because they have no outcomes in common. They're the opposites of each other, okay? So if you have 2 complementary events, automatically they are mutually exclusive. Consider the experiment of drawing a card from a standard deck. Okay, event A is a face card is selected, event B is a red card is selected, C is a club is selected, D is an ace is selected, and E is a black card is selected. So which pairs of events are mutually exclusive? So which pairs have nothing in common or couldn't happen at the same time, okay? Well, I would say A, okay, a face card is selected, and D, an ace is selected, okay? Can't have a face card that's an ace. I would also say, excuse me, B, a red card is selected, and C, excuse me, a club is selected. And then finally, I would say that B and E, okay, are mutually exclusive. So a red card is selected and a black card is selected. Now, of these pairs, which are complementary, which means kind of opposites, right? So the two that would be opposites would be B, a red card is selected, and E, a black card is selected, right? Those are total opposites, right? There are 26 of each of those type of card in the deck. All right, moving on. Events have been represented in a Venn diagram. Okay, state all the pairs of events that are mutually exclusive. So all of the events from that diagram that would have nothing in common. So all of the circles that are not touching. So A is not touching B, okay? They do not overlap. A is not touching or overlapping with C, and A is also not touching or overlapping with D. Okay, so there are 3, and there's one more. B is not touching or overlapping with D. Okay, so there are the 4 pairs of mutually exclusive events from that Venn diagram. Next, use the given information and the probability formula to determine whether events A and B are mutually exclusive. Okay, so remember, if 2 events are mutually exclusive, the probability of A or B, okay, should be equal to the probability of A plus the probability of B. That's a formula. We were just given that on the last page, okay? So what I'm going to do is I'm going to take the probability of A and I'm going to add it to the probability of B. Okay, so that's going to be 1/4 plus 1/3, okay, common denominator of 12. So that would be 3 and 4, so that's going to be 7/12, okay? That is the probability of A plus the probability of B. The probability of A or B is already 7/12, right? So the left-hand side equals the right-hand side. So since they are equal to the same thing on the left-hand side and the right-hand side, okay, all I did is I followed my formula, right? So you would say, since the probability of A or B is equal to the probability of A plus the probability of B, okay, the events are mutually exclusive, okay? And again, all I did is I followed the formula for mutually exclusive events, substituted the values into the equation and saw the left-hand side equal the right-hand side, so I know they are mutually exclusive. Next, a card is drawn from a standard deck of 52 cards. Use the formulas to determine the probability, okay? So we want probability here, that a 9 of diamonds or, okay, a heart is drawn. Okay, so let's deal with that one first. So first thing is, are those events mutually exclusive? Can you have a 9 of diamonds that is a heart? Okay, no. So these events are going to be mutually exclusive, aren't they? Okay, both those things can't happen. So what I do is I treat this like saying the probability of A or B, okay, where the 9 of diamonds is like your event A and the heart is like your B value. So you could write it like this: the probability, instead of A or B, you could say the 9 of diamonds or a heart, right? So there's your A and there's your B. Instead of A and B, I've used N, D, and H. So the probability of A or B should be equal to the probability of A, the 9 of diamonds, plus the probability of B, which in this case is H or hearts. So the probability of 9 of diamonds, well, that's 1 out of 52. There's only one of those cards out of 52, plus the probability of getting or a heart. Well, what's the probability of getting hearts? Okay, that's 13 cards out of 52, right? So when you add those together, you get 14 out of 52, right? Common denominator, you already had it. So 14 out of 52, which will reduce to 7/26. There's your final answer. There's your probability. Okay, in the next one, we have a 9 or a heart. Well, these are not mutually exclusive, right? Because you do have a 9 of hearts, aren't they? You do have a 9 of hearts. So in this case, I follow the not mutually exclusive formula. So the probability of a 9, or a heart, okay, will be equal to the probability of A, which is the 9, plus the probability of B, which is the heart in this case, but then I subtract the probability of the 9 of hearts, okay? What exists, that's both of them. So the probability of getting a 9, there are 4 9s out of 52 cards. Hearts, remember there are 13 out of 52, okay? And then I minus the 1 card that is the 9 of hearts, for example. So that's going to be 17 minus 1, that's 16 out of 52, okay, as a probability, and that will reduce to 4/13, okay? And there are your probabilities. Okay, next example. Blocks of different shapes and colors are placed into a bag. There are 3 cubes, 1 blue, 1 red, and 1 green. There are 2 pyramids, 1 red and 1 yellow, and then there are 5 cylinders, 1 blue, 1 yellow, and 3 red. Determine again, they are looking for the probability that a block selected at random, A, will be a pyramid or a cube. Okay, so when you draw something, can it be a pyramid or a cube? Okay, Can't be both, right? So these would be mutually exclusive, okay? They can't be both. So that means I go the probability of A or B, okay, which in this case would be like a pyramid or a cube. So there's your A or B events. It would simply be the probability of getting a pyramid, okay, plus the probability, okay, of a cube. That's it. Okay, probability of A or B is equal to the probability of A plus the probability of B. So what's the probability of getting a pyramid? Okay, so you take a look at what you have. There are a total of 10 shapes, but there are only 2 pyramids. So 2 pyramids out of a total of 10 shapes, plus how many cubes? There were 3 cubes out of a total of 10 shapes. You add those together, you get 5 out of 10, okay, which again will reduce to 1/2. Okay, so there's the first one. B, okay, determine the probability that a block selected at random will not be red. Okay, not red. So what I would do is that you could either go, probability 100% of the number 1 minus how many are red, or simply in this case, just add up, because there's small numbers of elements or objects in this case, right? I have 10 shapes, right? 10 in total. 5 of them are not red, okay? 5 are not red. So that's pretty easy. So the probability of not red, which is what they're asking for here, okay, would simply be 5 out of 10, okay, which is 1/2. Okay, so that one's pretty straightforward. Next, the next is determine the probability that the will be red or it will be a cylinder. So again, you have to ask yourself, do I have a red cylinder? Okay, and yeah, you do. You have 3 red cylinders. So these 2 events are not mutually exclusive. They're not mutually exclusive. So you have to use your non-mutually exclusive formula. So that would be like this. The probability of red or a cylinder will equal the probability of red plus the probability of a cylinder minus the probability of red and cylinder. Okay, so the probability of selecting something red, okay? Well, from B, we knew the number not red was 1/2, so the probability of red will be 1/2, right? Half of them are red. Plus the probability of a cylinder, well, there were 5 cylinders out of the 10 shapes. And then the probability of red cylinders, well, there were 3 red cylinders out of the total of 10, okay? So when you find your common denominator, that will give you, okay, out of 10, right? So when you add those together, 1/2 plus 5 out of 10 minus 3 out of 10, okay, that is going to give you 7 out of 10, okay? And there you go. There is your calculation for that one. Last question, okay? Tom and Andrew were asked to solve the following problem. 200 people with neurological symptoms, which include headaches and backaches, participated in a study to evaluate a pain relief medicine. All the people took the medicine and the results were as followed. So again, right off the bat, all the people took the medicine, okay? So they're all accounted for, and they're all part of these numbers that are going to follow. 60 people experienced headache relief, 126 experienced back relief, and 36 experienced relief from both. What is the probability that a person who takes the drug experiences relief from at least one of the 2 symptoms, neither of the 2 symptoms? So that's what we're after here. Those are our 2 questions. So it says, Tom decided to solve the problem using a probability formula. Complete his work and determine the answers to the problem. So first thing he does is he determines the probability of H, which is going to be headache relief, right? So that was 60 people out of 200. That reduces to 30%, okay, or 0.3. The probability of B, well, what would that would be? That would be the backache relief. That's going to be 126 people out of the 200 that were surveyed. Okay, so on my calculator, when I go 126 divided by the 200, okay, that's 0.63. So 0.63. Now, what I have to do is the next calculation, which is the probability of what? Headache and back relief. So there were 36 of those people out of the 200, weren't there? Okay, they gave me that value. So 36 out of the 200, okay, so that is 0.18. Okay, so complete his work and determine the answers to the problem. So the questions were at least one of the two symptoms. What was the probability of that? So let's deal with that first. Okay, so the probability of at least one of the two symptoms. So what would that be? That would be headache or backache, right? So I'm after this, the probability of headache or back. Now, they could have both, right? They've given me that value. So it's going to be not mutually exclusive. So if I add it, it's going to be probability of headache plus the probability of back relief minus the probability of both headache and back, okay? So when I fill those values in, this is going to be 0.3 plus 0.63 minus 0.18, okay? Add those together, subtract the 0.18, okay? 0.75. So there's your probability. Now in part 2, it says neither of the symptoms, okay? So neither. So that's kind of the complement, right? So the complement then is the probability is 100%, or the number 1, minus them getting relief from one, the other, or both. So that is simply just going to be 0.25. There's your complementary calculation there. Now, Andrew decided to solve the problem using a Venn diagram. Complete the Venn diagram to determine the answers to the problem. So what they've done is they've already put 36, okay, in the middle. Those are the number of people, remember, that experienced relief from both. Now, if I had, for example, with headaches, there were 60 people that had headaches, right? This comes from our logical reasoning and set theory unit. The number of people in just H would be this total 60 people that had headache relief minus the 36 that had relief from both. That gives me 24. So that's the number of people that had just headache relief, okay? Then for just back relief, there were 126 people that had back relief, but I take away the 36 people that had relief from both, and that leaves you with 90. Okay, so I have 90 right there. Okay, so then what I do is I add up those numbers. So I'm going to go then 24 plus 36 plus 90, that's 150 people. So 150 people, but they said they had 200 people that were all accounted for. So that means there are 50 people, okay, that are on the outside of those circles. Okay, now what are they asking? Well, they're asking the same thing here, okay? So in the first part of the question, I want to know how many people, okay, or the probability that people had headache or back relief. So you look in those circles, okay, H or B, it's everything in those two circles, isn't it? So it's the 24 people plus the 36 plus the 90. Those are all the values in the circle. And that's probability is out of the total, out of the 200 people, okay? That will give you 0.75, okay? And then 2, well, the number of people that had no relief, well, that's the 50 people on the outside of the circle out of the 200, okay? And that's 1/4, or 0.25. Okay, that's it for today, you guys. So make sure you're labeling those formulas on your formula sheet or somewhere in your notes that they're easily accessible when you are trying to go through and deal with these questions. As always, any issues, concerns, questions about homework, take a screenshot of it, email it to me, and I'll get back to you with some help ASAP.